Okay, so here we're going to take a look at a dihybrid cross example, and I just threw in a true breeding example as well within this example just to put two into one. So I've just identified what our alleles are going to be at the top, so always make sure you identify what your alleles are so that we're all speaking the same language. So here we have an example. If we have a true breeding round yellow pea plant that is crossed with a heterozygous round and yellow pea plant, what are the genotypic and phenotypic ratios of the F1 generation? So just a reminder that true breeding basically just means homozygous for both of those traits that we're identifying here. So we talked about round and yellow, and if it's true breeding, it means it's homozygous for both. So homozygous for the dominant traits. So I've written out the genotype of that first parent plant. Okay, that's your first step after identifying your alleles. The next one is our heterozygous round and yellow, so heterozygous for both traits. So I've written out that genotype as well. Okay, this is the cross that we're going to do. And I just color coded it, I don't know, I like color coding things, so maybe you'll also appreciate it. But after, I guess this would be step one, after we've identified our genotypes, the next thing we're going to do here is figure out all the possible gametes that each parent can produce. Okay, so if you look here, if we're going to do all the different combinations possible, you should hopefully see that the only possible gamete we can produce with this first parent will have a dominant or a big R and a dominant color, so a big Y. That's the only possible option. Right? We could produce 4 of those. But for our second parent here, we have more options. Okay, so I'm comparing each of my individual alleles here. Okay, so we can have a gamete that is big R, big Y. We could have a gamete that is big R, little y. Next, we could have a gamete that is little r, big Y. And then finally, we have little r, little y. Okay, so each of these gametes is distinct. Okay, all 4 of these could be produced from this parent, whereas this parent only has one possible distinct gamete. So when we cross these individuals, all I'm going to do is cross these possible gametes with all of these possible gametes, rather than doing 4 of the exact same thing here. Okay, if you did happen to do all 4 gametes that are the exact same and cross them, you're going to come up with the same final answer. You're just going to take the long way around to get there. Okay, so our next step then is to set up our dihybrid cross. So we only have one gamete here, so it makes our table nice and small. Okay, so our first parent, and then our second one will go across the top. I'm over-exaggerating my Y's because otherwise it's hard to tell them apart. Okay, so we'll fill in our chart. Sorry, I do this all the time. Okay. Once you have completed your chart, the question now is asking us for the ratios for both genotypic and phenotypic ratios. So we'll do our genotypic first. Always start with your genotypic ratios. Okay, if you look at your chart, you're going to notice that all 4 of these possible genotypes are different. If you happen to do that large chart, so you crossed all of these 4 gametes, then you would get multiples of the exact same genotypes, but you wouldn't have any different genotypes pop up. That wouldn't be possible. Okay, so you're supposed to write out each genotype as the ratio. Even though I basically just repeated the chart. But that's the proper way to do it. And we have a 1-to-1-to-1 ratio. Our last step here would be to give the phenotypic ratios. And I'm going to list all of the possible phenotypes of these plants, but you're going to see that not all of them are going to show up in this cross. Okay, so the best way to do it is always write out, so the first trait and then the second trait, always start with the dominant and the dominant, and then I'll compare that to dominant, recessive, recessive, dominant. This way I make sure I'm getting all the phenotypes. And then recessive, recessive. Okay, so what I mean by that then, right? So this is the example. We're going to have our 2 dominant traits, which is a round and yellow plant. And we're going to compare that to round and green, because that green is the recessive trait. Then next we'll do wrinkled, and then the dominant and yellow. And then finally both recessive traits, which is wrinkled and green. Okay, so those, because this is a dihybrid cross, we're looking at 2 separate traits. These would be all the possible phenotypes in a dihybrid cross. However, because this is a true breeding plant, we don't have as many distinct gametes, so we're not actually going to see all of those phenotypes. If we look at our chart and we figure out what each of the phenotypes are, you're going to see that this is round and yellow. This one's round and yellow, this one's round and yellow, and this one's round and yellow. So you're going to get, in the F1 generation, all of the plants are going to be the same. They're all going to be round and yellow. All 4 options here were round and yellow. We didn't have any of these other plants. Okay, and then you should reduce this to 1 to 0 to 0. And this is your final answer here. That is your phenotypic ratio.